Good evening, MOBISEC hackers. So, as I mentioned, today we're gonna switch topic and we're gonna focus on a high-level overview of the entire ecosystem, and we're gonna try to understand why security actually matters in this topic. Cool. So, what's the point of what we discussed so far? We discussed many of these security features in Android, and Google is investing tons of money in trying to secure the platform. So in this set of slides, I would like to discuss exactly what's the point, what are we trying to protect against, and why it's a complex problem and why it's a complex ecosystem with multiple parties involved. Okay, so again, we discuss safe. We want to keep mobile devices safe, but safe from what? And it's an extremely complex ecosystem, and we have a bunch of bad guys that try to do different things. And again, we're going to try to move on the what are these bad guys trying to do. So first of all, we're going to try to understand their different incentives and the different ways they can do damage, and what kind of a complexity and weakness we need to deal with we need to deal with in the context of the ecosystem, and why each of these complexity and weakness can actually create problems for us, the defenders. So I have a slide with an overview about the actual ecosystem. It is a simplified slide of the actual ecosystem, but as you're going to see, it's going to be quite filled with information. So we have different entities. On one side, we have the user, okay? And the user has a bunch of user data. So that's already the first important aspect that should be protected. User data is extremely valuable. And nowadays, user wants to use their device, and this device, of course, contains this user data, okay? And since these devices contain user data, that's why we want to protect them. Very easy. Now, who are the producers of these devices? This brings us to the second entity, let's say, of actor in the complex ecosystem. In our case, we have manufacturers and the operating system developers. In this case, it could be Google developing Android, or it could be Apple developing iOS. Apple and iOS have some kind of a closed ecosystem where basically Apple produces the devices and also produces the operating system, and that's about it. With Android, as you probably know at this point, is very different. Google is the main developer of an Android operating system. Android is an open source project, so additional companies or third-party companies are free to take the Android open source code base and somehow modify it and adapt it to their needs. In terms of manufacturers, again, we have many different types. We have some that are supported by Google, and so this leads us to the Google flagship devices, such as the Google Pixel line or the old Google Nexus line. But there are many other different manufacturers, such as Samsung and so forth. They produce their own phones, and they sell them as they please. Okay. Now, in these phones from different companies, again, in these logos here, I have Samsung, Huawei, and so forth. Each of these companies somehow take the Android open source framework and somehow modifies it, adapts it, and customizes it, and then this modified version is shipped into the device, okay, that they sell. Cool. And again, as we explored already, this kind of a customization creates issues. Again, we're going to touch a bit on this later on today as well. Now, on the other side, we have a different entity, and these are the app developers. These guys are the ones that create apps and want to publish apps to the app stores. Okay, so app stores could also be considered another entity and another, actor in the complex ecosystem. They have different goals. They want to be a one, place where users can actually get applications. They provide reviews so that users are a bit more informed about what's going on. Depending on the kind of market, you can have security scans happening all over the market and so forth. Okay, cool. So now in terms of apps, what kind of apps are people interested in, and what kind of apps the app developers are actually implementing? Well, we started many years ago with basic things like possibility of having a phone call or to send an SMS. But of course, nowadays you have crazy amount of different applications that are being developed for many different kind of purposes, such as social network mapping, IoT controlling, and things like this. Okay, you name it. Now, a lot of complex stuff. Unfortunately, there are the bad guys, and now we're getting to the bad guys. Um, there are people that try to somehow, somehow attack the user and attack the, try to get access to the user data as one of the main things they want to do. And, or, user data. Another thing they could do is to get control of the device, and then they could abuse the power of the device. They could make the device act as part of a botnet and so forth. So we're going to cover the different kind of malicious behaviors, but this is just to get an idea. So there could be multiple goals for an attacker. And again, there are two main ways that an attacker can get in, and two main patterns that keep emerging all over and over again. The first one is malware. Malware, we can define it as an application which has malicious purpose inside. This could be clearly malicious, it could be subtly malicious, it could be, annoying, but not so much. Again, we're going to see the different kind of malware today. But again, that's one main way. You have an application, and this app contains some logic, some part, some component that the user may not like. Okay, and which component actually is also providing some benefit for the attacker. The second main category is security bugs. Security bugs could affect applications. It could affect also the device itself. It could be the operating system, the hardware. There have been many different kind of bugs discovered throughout the years. Okay, and again, why are bugs important? Well, because bugs could be used by an attacker to actually get access to the system, depending on the kind of bug. Okay, again, not all bugs are created equal. We're going to have many slides on the different kind of bugs, what are the more important ones, and so forth. But again, to get you an idea, this is the second pattern that keeps emerging. Cool. Now, moving on, another entity is us. The security researcher trying to do something good about these security problems. And so what the security researchers do usually is to inspect, for example, applications. They could inspect, a given unknown application, and they could try to check whether the application contains malicious functionality, or they could check benign applications, and they would try to check whether this application contains a vulnerability that could be exploited by an attacker. Okay. Once a researcher finds these kind of problems, then depending on the findings, it could somehow contact the app developer to tell them, there is a bug, or if he found the bug in the device or in the operating system itself, he could contact Google or the manufacturer to try to get it fixed. Okay, so at the end of the day, the idea is that these app developers and Google would actually somehow push an update to the benign app that was vulnerable, or push an update to the device or the operating system that was vulnerable. In case of Google, who is also controlling the Play Store, maybe Google could actually remove the malicious app from the store so that the user could not get infected. Okay, and this is a very simplified view of the ecosystem, but again, simplified, but still the slide is quite dense. Okay, so you have different entities and actors that you need to take into account when coming up with a solution, or trying to understand the world around us. Okay, there are some things that seem trivial, but if you consider the bigger overview of how things are, they may not be as trivial as you may think. Okay, so try to keep this in mind. Cool. I want to dig a bit deeper into some of these actors and some of these entities in the ecosystem, and why they create problems and what's their role. First of all, we have users. Users are probably the main problem of the ecosystem. They are highly rational creatures, and they're very distracted. And depending on the kind of user, they have well-known interests, let's call it that way. And it could be that they really want to download and play a specific game at all cost. And one scenario here is that maybe there is a game for Windows, but it's not for Android, but this user doesn't care. It's like, there is this new game on Windows, I want to play it on my phone. And so this guy would actually go on the Play Store and try to find this specific game that doesn't exist for Android, but he tries to find it on the Play Store. And that's maybe how he gets infected, because maybe a malware, a malicious actor, actually wrote an app that looks like the game on Windows and wrapped it up as a, looking like a game, pushed in the Play Store, and this user that really wanted to play this game actually gets infected and downloads the, what is seemed the game, but is not. Okay. We're going to have many examples, but you get an idea. Another problem is that some users are very, very interested in browsing some very interesting particular parts of the internet. Again, some people are more, I really want to access the website. And in some occasions, they really get out of control and they start clicking around, downloading whatever the website is asking them to download without thinking twice about, yeah, maybe, it just, this website is trying to push me to download and execute this piece of code, but, maybe I shouldn't do it. And the other thing about these users is that they're not machines. They are users, they're humans with feelings. And when they're under pressure, they tend to do stupid things. So one trick, is to somehow bring the user in a way that is under pressure or is stressed out or is like, please, you need to do this very, very urgently. Or this is not like is always a threat. It could be something like, oh, congratulations, you have just visited this random page on the internet and you won an iPhone. But to claim this reward, you need to, log in on this fake Google page very, very fast. Otherwise, you don't get the iPhone. And so the user stresses out and gets to the page and put the credentials there. Okay. So this under pressure doesn't mean that I always tell you, you know what, give me all your data or give me that amount of money, or is more, create a sense of urgency, and this pushes the users to do stupid things. Okay, so pay attention about the users. And this is a very difficult bug to fix. The other big thing is applications. Again, developers write apps and they publish them on the app stores. And one of the problems here is that the bad guys who could take these applications from the app store and somehow republish them on different stores. As I mentioned many times, there is the Play Store, which is considered the central place where people should get applications, but in different countries, there are different third-party stores where there are much less controls. And so it is possible for me to get an application from the App Store, and then I modify it a bit, and then I push it on the third-party store, and maybe that's a way that I can infect users. And as a user, it's tricky to understand whether an app is actually malicious or not, because how does a normal user know that they're different? And if they're different, can it be that it's just a different version with no malicious thing? So it gets complicated, and that's another common pattern on how users actually get infected. Okay, they maybe have access. They don't have access to the Play Store. They only have access to this third-party website. Maybe the legitimate developer didn't want to publish their own app on this third-party website, but the malware goes there, simulates that is this application that the user wants, and that's how the user is convinced to actually download this application. Okay, another thing are devices. Again, there are many different players, as I mentioned, and many different hardware manufacturers. And Google developed AOSP, so the Android open source project. But again, there are these OEMs, these original equipment manufacturers, that somehow take this AOSP and customize it and put their own things and so forth. And in the customization, they could customize the software. They may have different hardware, which means they may have different drivers for something. So some of these customizations is not just fancy UI things, but it could be something really needed because the hardware is different. And depending on how self-contained these modifications are, then you may or you may not be in trouble. Again, there are also many different Android versions, and it's difficult to, for example, if there is a bug in Android 10, it's difficult to take the patch for Android 10 and reapply it to all the different old versions of Android. So the other problem is that not all devices support all the versions. So it could be that there is a bug in Android, let's say 9, and then is only discovered in Android 10. And so maybe Google fixes the bug on Android 10, but it doesn't fix it on Android 9, 8, and 7. And maybe you have a device that the latest version they can run is Android 7, let's say, okay? And that's it. So even if there is a known bug out there, this phone will never receive an update. And this happens all over again, over and over again, okay? So that's another aspect. The fact that we know the bug doesn't mean that all the users are gonna receive a patch. And again, it's not that, I only go stuck on Android 7, but then I get all the updates on Android 7. it could be that even if there are some updates on Android 7, maybe you don't get them. Okay, there are different policies and different support levels for each specific phone, and it is an item that should be taken into account. Usually, most devices keep getting updates only for 2, 3, max 4 years, not much more. And this is an aspect that many people are upset about, because you have these wonderful devices that are still properly able to run at decent speed, all the applications you need, but on the security aspect, they lack. They lack a lot. And I, for example, was forced to get a new phone because my old one was not supported anymore, and I didn't want to have a phone that was not patchable. Let's say, with every month there are new bugs, and these bugs would also affect my phone, and I wouldn't have any choice then to get a phone that was not updated. Okay, and the phone was perfectly fine. So that's one item that people are really pissed about. Again, it's not trivial to actually support all the different phones, also the old ones where maybe they can only run Android 8 for some reasons because of new features in Android 9, Android 10 that require specific hardware, and maybe these old phones don't have it. So I'm not saying it's trivial to actually make sure that each phone can run all the versions. And if you get stuck on an old version like Android 8, then it's tricky for Google to take all the patches that arrive for Android 10 and somehow port them back to all, Android 8 and Android 7, Android 6, and so forth. So it's a very, very complicated problem. And I'm just saying here that for a normal user, that's somehow an aspect that they don't like, because they're somehow forced and pushed to change phone very often. However, for the majority of users, they don't even know about these security things. Security updates are just an annoyance. So, after 2, 3 years, the phone stops complaining that, oh, you should update this thing. No, there is no, you should update anything. So great. Life is beautiful. They mostly don't care. And so, that's why people get stuck with old phones, and, they're not particularly concerned. Cool. But if you care about security, then you don't have much choice as of now. There is also a dashboard with the Android version distribution. I think at some point they stopped updating it, but basically once it was working, maybe it's still working now, basically shows the distribution of the Android versions of all the phones contacting Play Store. So once you have an Android phone and you have Play Store installed, basically your phone contacts Play Store repeatedly, to download an application or to check for updates. And the Google keeps statistics on what kind of version of Android your phone was running. And in the, whenever there is a new version, you would expect that some people or a significant portion of the users will get the last version, but usually that's not the case. For a year or so, the percentage of phones running the latest version of Android is very small, like maybe less than 2, 3, 4%. Okay, again, depends on the cases. Hopefully this number is going to change, and so this proportion is going to change. But the rule of thumb is that many or most of devices do not run the last, or maybe even the one just before version of Android. Okay, and again, this to keep in mind that the fact that there are security bugs and the fact that Google knows them and the fact that they are patched doesn't mean they actually reach these patches. Doesn't mean that these patches reach all the phones out there. Again, this brings me again to this Android fragmentation problem, which I mentioned in the past, and is considered by many the biggest problem of Android security, because basically you have hundreds of devices with custom hardware and software, and even if you find a bug and you patch it, then propagating this patch on all these different hardware and software is really, really complicated. And again, this customization makes development and patching very tricky. And again, this is not a good thing for the community, for the ecosystem, because there are many phones out there without patches. Now, I have a slide describing the long life of a security bug, just so that for those of you that don't know, what happens. So now you know what happens when people find bugs and how the process works. So at first, somebody finds the bug. Okay, this could be a security researcher. It could be from Google, or it could be an external one. Again, you find the bug. Great. What do? You disclose it. Okay, so you take the bug and then you tell somebody. You don't publish a blog post, you don't write the paper before. First of all, you disclose it. So you would report the bug to Google in this case because it's Android security, and then somebody needs to pick it up. So you need to hope that the bug reaches the Google employee. There are many people complaining sometimes that you open a bug report, you discuss the bug, and then you get as a reply, no, doesn't seem very very important, and maybe the bug is very important, and maybe that's because the specific person that somehow reviewed your bug really didn't get the issue you were talking about. It could be that is an expert in another field. It could be that your issue was not let's say it was not clear enough and it was a bit misleading. Miscommunication happen. It's not that there is a maliciousness involved, is that miscommunication can happen, and sometimes the bug is not recognized as a bug. So you need to hope that your bug and bug report reaches the right person, and if everything is fine, Google acknowledges the bug and says that yes, thank you, we're going to work on a fix, and they somehow keep you updated. The timeline can vary a lot. Again, I'm going to show some numbers later, but the rule of thumb is that usually a vendor should patch the bug in 90 days. But again, for some bugs, they actually take much longer. Again, it could be months and months and months. Okay. There is a thing it was called responsible disclosure. Now people are pushing to use a different term, that is coordinated disclosure. And the idea is that before writing about your bug publicly, you tell the developer and then you wait. The industry standard is to wait 90 days before going public, after which it's considered okay to actually go public. And the idea is that the vendor had enough time to actually fix it, but after a while, it's bad for the security of the users to keep a bug private for maybe 5 years, because in the meantime, a bad guy could actually have discovered the same bug and you could have used and abused the system. While if you discuss it publicly, then at least the users that really care about security may have a chance to fix the thing for themselves. They could say, oh, this bug affects a specific feature, I'm going to disable this feature because maybe I don't care. Information is good in general. And again, as a trade-off, another thing would be to say, I publish the bug publicly the day after. That's the other part of the, on the other side of the spectrum. That's not considered best practice because, in that case, the vendor doesn't have any time to actually develop the patch and then, testing it and so forth. And, if you go public with the bug the day after, depending on the bug, it could be that the vast majority of users, even the ones that care about security and keep their phones updated, are affected by this bug. Again, there is a huge discussion in the community. Not everybody agrees that this 90 days is the good, this is the good trade-off, but that's more or less what is considered the industry standard. And again, after this, you can publicly disclose the bug. And I want to also mention one thing about this responsible and coordinated disclosure. Again, traditionally it's been called responsible disclosure, but there is no real obligation to follow this practice. It's something that I personally do, and I think it makes sense depending on the bug. But some people believe that's not the case, and these people didn't want that this procedure or this way of handling things will be associated with what is the responsible way of doing things, because there are some people with strong beliefs that this is not the best way to do things, and they don't want to be considered unresponsible. So somehow there is a push from the community to switch terminology and use something like coordinated disclosure, which just means that you coordinate disclosure with the vendor. You give them a heads up, and then they can say, okay, we're going to fix it, or now it's fixed, okay, you can go public. So there is some kind of a discussion. But again, the coordinated disclosure term does not associate any, it's the responsible thing to do, or it's, there is no morality associated with this procedure. And that's why people are arguing for changing the name. Okay, cool. So once Google knows about the patch, and maybe it commits the patch in their own repositories, then you need to distribute it. And good luck with it, in a sense that, first of all, Google needs to somehow tell the other manufacturers, hey, you know, there was a bug here, and is the patch, please try to apply the same patch to your system that are customized. And usually patches are published as part of this monthly security bulletin. So every month there is a new bulletin with a bunch of bugs that have been fixed. It does not mean that they were found in this month. It just means that they were fixed as part of this monthly release. And usually these bugs reports are actually very informative. You have, in many cases, you have actually the link to the Git commit that fixes the bug. So they're very, very informative. And you know, this is what Google does, but in the background, they need to communicate these patches to the other vendors, and so that the vendors have a chance to know in advance without need to wait for this public monthly security bulletin release and fix their own things. Supported Google devices eventually get a patch, but as I mentioned before, not all devices are actually currently supported. And another thing is customization is problematic, and the customization is one of the main drivers for this fragmentation. And the idea is that Google sends the patch to a third-party company X, but again, this third-party company X likely has customized some aspects of the Android operating system. And so now company X needs to apply the patch, but is the patch compatible with the customization from the company X? It is not simple to always and automatically understand, yes, I can cleanly take this patch X from Google and apply it to my customization, or to Android with my customizations. It's not that trivial. And you know, what if the patch conflicts with the code that I just slightly modified? Or you know, maybe, you know, it doesn't conflict directly, but maybe by including the patch, everything becomes unstable. And you know, maybe I do this, but maybe it's going to introduce some backward compatibility problems. And again, most of these problems may not be about security, but you know, if these problems affect the usability, it's still a huge issue, because absolutely usability triumphs. You know, it takes priority over security. If a patch breaks something that's considered as a huge failure, people are going to be upset. Most users don't care about security anyways. So really, they need to make sure that once they have a patch, this patch is not going to affect the other functionalities of the system. Well, you could say, okay, you can run all the tests, but it's always tricky, right? Because are these tests really comprehensive enough? Now, you probably have heard about unit tests and different tricks to actually test things properly. But you know, depending on the patch, depending on how serious the patch is, or depending on what kind of component the patch is touching on, then this stuff can be very tricky. For example, if you have a driver and there is just you know, the security bug is that there is a missing check, and the patch is just adding an if checking for a specific condition, then it's probably going to be fine. Okay. But if the bug is some kind of UI stuff where the patching it would actually require a rewrite of the UI stack, and maybe the, you know, a different vendor completely customize this UI stack, well, maybe it's not possible to take the patch and clean applying it. Maybe the developer needs to study the patch, study really maybe the new implementation of an aspect, and some port the new implementation to the customization one, the customized one. Okay, so this stuff can get really, really tricky. And again, how tricky it is depends on the kind of bug, what the kind of component affects, and so forth. Cool. The other thing is patch deployment can be risky. Like, okay, now I'm kind of confident that my patch somehow, you know, it keeps things stable, it fixes the bug and so forth. But now, you know, think about the scale of this. There are 2 billion, you know, Android active users out there every month. And if you take a patch and this patch somehow breaks things, it can be a disaster. Okay, so there are techniques to try to do some kind of damage control, where basically instead of just pushing the update to every possible user at the same time, you do what's called the A/B testing. So you push the update to a small portion of users, and then you wait that these guys actually update the phone, and then, you know, you hope that everything is fine, you monitor the situation, and if everything is still fine after a while, you know, okay, the patch was not, it did not break any device, so everything should be fine, and now you can release the patch to additional users. Of course, it's a trade-off again, right? Because it happened to me that the security bulletin kicks in, comes out maybe the 5th of every month. And sometimes I get my patches on the 15th of every month. So 10 days later, the entire world knows exactly which bugs were fixed, how they were fixed, where is the component that was fixed, and so forth. Okay. And why am I getting this delay? Is not just me. I mean, I try these things multiple times. I could go on the, check for security updates. I do check for security updates, and there is no, there is no security update. So my understanding is that this is part of a A/B testing methodology, where they basically enable receiving updates for some users later on, so that they can monitor whether there was a broken patch and so forth. Okay. And again, it's a trade-off, because they are calmer, that they can do these things with more confidence, because they know if something is broken, it's going to be broken for first with a small part, and so they can block the deployment to all the other users. But on the other side, they're going to leave my phone exposed for maybe 10 days. Okay. Which maybe nobody cares much, but that's a problem. Okay. Cool. I mentioned already that then Google kicked in with this Project Rebel, trying to really try to fix this problem. And again, before Project Rebel, there was no clear interface between the operating system framework and the vendor implementation. And so once, when Android operating system is updated, then the vendor may lose time integrating the new patches, and this would introduce cost and overhead and delays. And this means that the users will get the patch later on, okay, which is bad. Project Rebel helped a lot defining a clear interface, so that a vendor knows that, this is where I should put my customization, and everything else is for Android. And the Android folks said, if we have updates, we're going to update the Android part, not the vendor part. Okay. So we're going to leave the vendor part alone. So as long as you put your modifications in the vendor part, you will be able to take our Android modifications and somehow apply the patches to the Android component without problems. And again, this is useful for non-security patches as well, because it means that you can apply these patches much more, confidently, without risking to break stuff. So this is more the diagram on how things were and how things are. This is the previous part, where basically you have an update, and this update could actually somehow also touch on some vendor customized components, while after Android 8, so with Project Rebel, you have a much clearer separation of things. This is kind of a goal, doesn't mean that everybody follows it. And again, I mentioned we have an update, an upcoming paper at Security and Privacy, where we actually studied all these customization efforts from these third-party manufacturers, and we found out that they are not all following strictly this kind of a procedure and this kind of a mindset. And again, I'm going to put the link at some point when the paper is out. But again, in terms of an effort, I think it makes total sense. One other note is that, again, most devices don't get security patches. I mentioned at the beginning that most devices run an outdated version of Android. And for these devices, usually there are not patches being distributed. Again, even with all this progress, security bulletins, Project Rebel, and so forth, many devices don't get update. And most devices get support for about 2-3 years. And again, it's a painful point to accept. And this applies even for Google flagship devices, such as maybe the Pixel or the Nexus. And you can find tables online. So this is not secret. You can find tables online that they tell you, for this specific phone, this is the deadline to receive the last update, the last security update, and so forth. And you can see that, if you buy a Pixel in October 2018, then you have 1 year left to get the security patches, after which you don't get anything else. Okay. Again, you can go on this link to find updates for the newer version of phones, and which one is the deadline to get security updates for each of the phone. But you're going to see that even for very recent phones, the deadline is not in 10 years, is more likely in 2-3 years. Okay. So moving on, one of different entities, like the security researchers. This brings me to where we kick in and what is our goal as security researchers. We have two different things. The first one is identify malware. So the idea is that once we find a malware, this malware is found and we put it on a blacklist, on a block list, and somehow we know that, oh, if you find this specific sample, then we flag it as bad. The idea is that there are many techniques to then try to categorize this specific sample as samples that are similar to the sample that they already classify as bad as well. Okay, so there are many approaches, signature-based approaches, behavioral approaches. There is an entire community trying to take a sample and maybe try to find a generalized rule to classify as malicious every other sample that looks the same under many aspects. But again, in general, it's an open problem, is not completely solved, and there is a lot of research and money being thrown at this. There are many companies behind these efforts. The second big category we as security researchers focus on is finding and fixing security vulnerabilities. Again, once they're found, we report them to Google, or this applies, of course, not only to MOBISEC, but mobile security, but also to any other piece of technology. And somehow there are these things called bounties, and called bug bounties, and these are things that some monetary rewards for submitting bugs, and they try to incentivize. If I find a bug, they try to incentivize me submitting it to Google so that Google knows about it, they can fix it, they can deploy a patch for all the users. So let's spend a bit more words on these bug bounties. So if you are not familiar with this, maybe news for you. If I find a bug, or if you find a bug and this bug is serious enough and you tell it to Google, Google is going to give you money. For some bugs that we found in the past, we actually got some thousands of dollars and so forth. Nothing crazy, but again, these bugs were nothing gigantic. But I have some friends and some colleagues that made some serious money submitting bugs to Google or to other vendors. So this could be quite profitable. Does it mean it's trivial to do it? No. Does it mean you can have a life as a bug hunter and it's a steady source of income? I don't think so. There are people that can do it, but in general, nothing guarantees you they're going to find more bugs in a month. So it's not like a monthly salary you receive, but it could be a nice addition. Again, there are some successful people that are able to cope with the stress of not getting a steady salary, but since once they hit very hard, they are actually happy anyways. Again, so it's possible to be successful in the business of just finding bugs and getting rewards, but it's much more difficult than what they're trying to convince you. And again, the idea would be to keep security researchers motivated to disclose bugs to the proper entities. And bugs really have a major role in security, because if there is a specific kind of bug, an attacker could somehow use this bug to compromise a system. And again, this is not only about mobile security. It could be a server. If you get access to a bug that affects an application listening on a specific port, then maybe you can use this to attack the server. Now you're on the server, you can see other things. You are in the internal network. It's not that each bug needs to be the end of the game. It could be that a bug gives you access to another part of the attack surface, and then from there you can go to your goal in an easier way. The other thing about bugs is that some bugs are not directly accessible from outside. So it's not that from outside, a bad guy can actually attack you, but it could be that some bugs could be used by malware to bypass security barriers. So for example, there are some bugs class that are like permission bypass. So you're able to do operation X without having permission to do operation X. And there are some scenarios where maybe you stole a malicious application without knowing it, and then this malicious app in theory wouldn't be it wouldn't be possible for this app to do operation X, but since it has this bug, you can exploit the bug and do operation X anyways without even asking the user. Okay, so now you get the two different ways of why bugs are important and why companies and researchers throw a lot of time and money to try to find all the bugs in the fastest way possible. Again, when I say good money, I say good money. So some bugs are extremely valuable. And again, there are many aspects that determine how much a bug is valuable. We're going to have many slides on the topic on, trying to classify different bugs and try to understand why this bug is better than the other one, or try to understand, if it even makes sense to compare two different bugs, because maybe there are bugs associated to different threat models, different kind of attackers, and they are not easily comparable. So all these kind of discussions, we're going to postpone it for the future. But again, the idea here is that not all bugs are created equal. Some bugs are more valuable than others. And the holy grail of bugs is usually so-called RCE. RCE stands for remote code execution. And these are the bugs that allow an attacker remotely to get access to get code execution on the user's phone. Because once you get code execution on the user's phone, then you can do everything else that you want to do. Okay, so that's more or less the big objective that most bugs have. Not all bugs are so powerful. So maybe a bug cannot do much, but it can just maybe read some sensitive information that it shouldn't be able to read. So this is of course less generic than having being able to execute code. But again, depending on the situation, it could be very valuable as well. But again, the most valuable usually are these remote code execution bugs. And as a trend, these bugs are giving you a lot of money, depending on where you find it. And again, there are different ways that the bug is categorized. So here you see severity, critical, high, moderate, and low. We're gonna dig deeper on how this category or the severity is assigned to which kind of bug later on. And you see, this slide is just to convey what kind of money we're talking about. So we're talking about $100,000. And if you move forward with time, depending where you get this code execution, the amount of money you can get is really a lot. Okay. So is it easy to find these kind of bugs? Not really. Also because there are some rules. If it was a bug associated to a different component that somehow also affect this, maybe they're not eligible. So there are some rules in place. But again, we're talking about a lot of money, and this somehow tries to convey, companies really care a lot about knowing this money. And if I have Google that pays me this amount of money for these bugs, I will be encouraged to tell Google about this, not only for my moral, from the morals perspective, that I want Google to fix it so that people are protected, but also in terms of monetary things. And you may ask, okay, but why so high? If for a bug I get 10,000, why do they need to give me 1 million? Well, because there is some kind of another community that really looks for these bugs, and some of this community members some are the companies that really want to know about the bugs so that they can fix them and protect their users. Some others are big stake entities such as governments, and so forth. And these governments usually they have a lot of money. So usually governments are willing to pay even more than this, than these amounts. And trying to stay in the game, Google actually tries to raise also the money that he will pay, so that the researcher is not like, oh, Google pays me 10,000, but this other guy pays me 1 million. Of course, I need to go with the other guy, but it's more balanced. Of course, deciding where to sell the bug, it's up to the person that found the bug. Usually it's if you submit it to Google, how the bug is going to be used, they're going to fix it and so forth. If you submit it to government, you don't know what's happening. Depending on the government you interact with, it could be it could be used for against terrorists. It could also be used against activists. Again, really depends on the governments. And once you sell it to governments or to different entities, then you may not be fully aware about how the bug is used, and that's why sometimes it's safer conceptually to sell it to Google. Okay, but again, it's something to keep in mind, that is not just you sell it to Google. There are different entities. These different entities come out compete, so there is a market for this. This drives the price up. The price is so up that some people say it doesn't even make sense. That maybe for a developer working at Google is much better to leave Google and submit the bug through these bug bounties than to actually work there, and so forth. Okay, cool. So in general, the attacker's goal, usually the holy grail, is to run code on your device and do whatever it needs to do. And this somehow gives structure to the rest, some of the, a big component of the rest of the class, not only for today, but for the next, I guess, 2-3 classes. And again, the two important topics we're going to explore is malware analysis and detection and containment. So we want to understand how to analyze malware, how to detect malware, and assuming we cannot detect them all, how we can we contain it so that it cannot do as much damage as it could possibly do. And the other big topic is about vulnerability, how to analyze them, how to find them, how to prevent them, and how to patch them. Okay, so these two topics are the main trends that we're going to explore in the following classes. And today we're going to focus on this malware analysis. And for this lack of that, the slide of that, this deco slide, I am done. And okay, I'll be back in 10 minutes to discuss malware analysis in more detail. See you in a bit.